So let's continue. So mean, max, and sum. Sum works with numbers only, and mean and max work with different types. But you need to understand with types that you can compare. So if, for example, I have a list A with, let's say, a list that consists of lists. I'll do example like that. So I have a list that has three list elements inside it, and each list element have two integers. Let's try to sort this one. A dot sort print A. Does it work? Yes, it does. And actually, the reason it works, that lists can be compared to each other as well. What it does compare first number to other first numbers. And then if these first numbers are equal, then it compares second numbers. So basically, if I change 5 to 1 and sort it again, I'll see that I have 1, 2, and then 3. So lists can be also compared. But what cannot be compared is, for example, numbers with strings, numbers with lists, lists with strings, and so on and so on. So be careful when you do that, and use sort method wisely. What I didn't show you last time with strings, and actually it works with lists as well, is a in operator. So how it works? Print, let's say, I'll start with strings. World in hello world. We get true. Uh, what does it do for us? So we can check if something, for example, this substring with a word world, is does exist in a larger string in this example. So if world is in hello world, we will get true. If, for example, I change it to world with T, I will get false because there is no world in hello world sentence. You need to know that this comparison is case sensitive as well. So pretty much everything is case sensitive. This means that if I have a world with uppercase W and I have world with lowercase w here, so this is not a match. So I'll get false as well. So this works with strings. We will need it for if-else if statement if we will be using later. But also it works with lists. So I can check if, for example, let's say math in courses. So if there is math in courses, I will get true. If there is no math in courses, I will get false. And instead of that math, you can have any data type you want, because you can have any data type in list. For example, I can check if 10 is in numbers. And I get false because there is no 10 in numbers. This is a very good way to check if some substring or some element exists inside another element. So 10 in numbers, there is no 10 in numbers. If I change it to, let's say, 1 in numbers will give us true because we have 1 in numbers list. I will continue. So what we also want to see, we want to see a better conversion from string to list and from list to string. Because if I do it now, for example, I want to take hello world string and convert it into a list. I told you before that we have this list method that actually takes something and converts to a list. So if I take hello world and convert it to list, I will get this sort of list. Basically, each string symbol or character will become a separate list element. and it is not what we actually want in the most of the times. So what we can also do, we have a separate method, print, and I will use the same string, hello world, and use this split method. Split method. Now, this is a string method. Okay, so it's not a list method, it's a string method because we apply it to string. But the thing is, when you use this method, you get a list, and in our example, we get a list with two elements, hello and world. Space between them was deleted because we don't have space in hello or world or anywhere here. So we have two separate elements. The reason for that is how split method works. By default, split method uses spaces to split strings. So basically, it takes everything as an element, then it sees a space. So this means this element is already finished. We delete space and start looking forward. So if I add here, for example, planet also, I will get a list of 3 elements, and so on and so on. Method split can accept an argument. This is a separator. So by default, actually we can use it without sep. By default, it is a white space. So that's why it works like this. But we can change it to anything we want. For example, I put O letter here, and I'll see the different list in the output. So my other list doesn't have any letters O, because it used O as a separator. So we have O here, we get hell, then we get space W as a second element, we delete this O from world, RLD up till the end is a third element. So we can choose what separator we use, and it must not be just a string with one word. For example, we know that we separate words with comma, and we usually do comma white space. So we have two characters here. So if I wanted to make a list of elements separated by comma, I could use a comma white space separator to get it right. So hello world is one element and the planet is another element. Because it's a string method, it's not a list method, and we know that all string methods return a value, so we can use this to save it somewhere else. Let's say I do words. Print words. What data type did I get for words? It's a list. So split method splits string and creates a list of elements from that string. So words is a list. This means that we can work with words like we would work with a list. The reason I saved it to other variable is that I want you to show how can you do the same thing but backwards. So let's say we have a list. For us, we have a courses list. And I want to create a string from this list, from all of its elements. So I can use str method, we know it, str.courses, but I will get exactly the same thing I had when I printed courses. The only difference is that printing courses on line 46 gives us a list, so it's a list. And by that method, using method str, we created a string from the list. So basically, this is a long string with characters. It's not list anymore. And this way is not a good way to convert lists to strings, because we're pretty much sure we don't want these square brackets, we don't want these quote signs, maybe we want commas only. So what can we do is to use another string method that takes a list as an argument and creates a string of it. And the method looks like that. So first of all, uh, you need to provide a string that will be used as a separator. For example, I put 3 asterisks. In order to join list elements into a string, we will use a join method. And if we look at the snippet, we can see that this method accepts an iterable as an argument. So what we can do with it, we can put our courses in here, because courses is definitely an iterable courses. And in return, we will get a string created from our elements and separated by this little string here in the beginning. So if I wanted to put like spaces between them, I would put space in this little string. If I wanted to separate with comma, I would put comma space and do it like that. So split string into list, and join joins listed items into a string. So you can use these two as well to make a better conversion. One more interesting thing about lists is that lists can be added to each other. So I can do print courses plus numbers, for example. Yep, in the end, I will get a mixed list with all of my courses first and then all of my numbers. You might see a warning here. Basically, what it warns us, it says try not to create mixed lists. So basically, if you create a list, it's better when you have same data types in one list. Sometimes we need to do mixed lists for some reasons, but usually it's not a good idea. That's why PyCharm does a warning here that says expected type list with strings inside, and got list with integers inside. So basically different types, it might cause you problems later. That's why PyCharm does that. But you can uh, like add one list to another. So for example, you can also do slicing. I can do courses, let's say from the beginning till third, plus courses from sixth till the end. This will work as well. So each slice from the list is a list, and we already checked it. So if I take more than one element, it is a list. So I can add 2 slices from same list, for example, and create another one. So it works fine. And the last thing about lists is how lists are stored in a memory and what makes them unchangeable. I will give you a simple example. For example, I say that a equals to 5. Then I create another variable. I say b equals to a. And then I'll add to a. Remember, I showed you this way of changing the value of the variable. For example, let's add 10. Let's try printing them. A, comma, b. So what we see here, we see that we created a variable a, then we put a variable's value inside variable b. At this point, both of them are equal to 5. And then we changed value of a by making it equal 15. So a is equal 15 and b is equal 5. Everything is logical. It will be same thing with strings. For example, I'll just make strings of numbers, not to waste time. So it will work same way with strings, but it will sum differently because strings are added one to each other, not summed like numbers. But it will still work. So basically, if I want to make a copy of a variable, I can use this logic. So b equals to a, and now b has a copy of a's value. It works with strings, integers, and so on and so on. What it doesn't work with is lists. So what we have here, we have a because these are strings. Strings are added one to each other. So we had 5 plus 10 is 510. We work with strings. It doesn't work like that with lists. So if I do courses, let's say courses 2 equals to courses, so I should have made a copy. And I will do some changes. I say that I will append, well, let's append art to courses, and courses 2 append, let's say, economics, and print them both, courses and courses 2. So what happened now? If we look at the output, we will see two exactly same outputs. If we check the code, that it's I'm 100% sure that I appended art to courses variable, and I appended economics to courses too. So what I expect it to do is appending art to the first one and appending economics to the second. But I have both appends worked for both lists. And the reason for that is how lists are stored in memory. So if we speak about simpler types, it's numbers, booleans, non-type, strings, the value is stored within the variable. So basically, variable stores the value. If I say a equals to 5, this means that 5 is saved to a variable. When we speak about lists and actually tuples as well and other data types, tuples are not changeable, but lists, dictionaries, for example, it is done a bit differently. So the variable has not the list itself inside it, but a link to other place in memory where the list is stored. So when I do that, I do say that courses 2 now store the link to the same list as courses. And basically what I have now, I have two different variables that address the same list. And in order to make a copy of a list, we can't use just this simple way. We need to add a copy method. So what copy method does, it takes a list from variable and creates a copy of it. So now we have two variables with same lists, but it's not one and the same list. It's two exactly the same list that are stored in different parts of the memory. And if I use it now, I can see that courses is now a separate list that had art appended in it, and courses 2 had economics appended to it. So if you need a copy of a list, you can use copy method to get it. Otherwise, if you leave it without copy methods, you will just get two variables using the same list. And that's actually what makes list changeable.
I have a question.
Yep.
So the equal sign here with list makes it working vice versa, right?
Equal sign.
Yeah, well, if we are writing course 2 is equal to courses, it makes courses to equal to course 2 as well,
Well,
which means that if we will change the courses 2, the courses will be changed as well.
yes. Well, I will explain it once again. So, if we store a list inside a variable, we don't store this data type itself. So the list itself is stored somewhere else in the memory. I can actually use Paint for that. So let's say we have a variable 1 here is equal to some list 1, 2, 3. So we save it this way. What actually happens is that list itself um, list itself is stored somewhere else, let's say somewhere else in the memory. And what variable 1 stores is a link to that list. So basically, when we create variable 2 and say variable 2 is equal to variable 1, we don't store a copy of a list. What we do store the same link. So basically now variable 2 has another link, but they have linked to the same list. Mm-hmm. So we just have two variables that work with one element, with same element, and we can have 3, 4, and 5, but they will all use the same element. So by doing a copy, by using a copy method, so I will add it here. Yep, dot copy. By using this dot copy method, we don't just copy this link, but what we do, we copy a list. So basically, we take a copy of this list, create a copy of this list in some other place in memory, and now variable 2 will store a new link to a new element. So that's the difference between lists and other data, like simpler data types, because numbers are stored right here within the variable. Mm-hmm. Strings are stored the same way. Lists, dictionaries are stored somewhere else, and we only store a link. So basically, copying it without copy method just copies the link to the same place. So let's say an address.
Mm-hmm. Thank you. Thank you.
You're welcome. This is it about lists for now. I will start explaining tuples, but lists are a lot. Let's say there are a lot more different ways working with lists than that. We need to continue learning Python. So we will see this a bit later. So what will I do now? I will comment all of this out. I will copy. Let's copy our courses somewhere here. And I will go back to this table. So list allows duplicate members. We'll check that. It is totally true. List is changeable. Yes, we can index one element, give it a new value. We can also use methods to change lists, and we still have the same list. List is ordered. Yes, every item inside the list has its own place or own index, and list is created with a square brackets. List is the most commonly used type of those all, of those three. I'm not talking about dictionaries now. So tuple. Tuple is quite similar. So if we look at these three cells, we see that allows duplicates. Yes, ordered. Yes, but tuple is not changeable. Let's change our list here, courses, to have round brackets instead of square brackets. So now it should be a tuple. And before we continue, I want to show you how we can create an empty tuple, because sometimes we will need that. So empty tuple can be created by, let's do print type empty tuple by two ways. It's either empty round brackets type tuple or similar to list with a tuple method. But usually people use round brackets and square brackets for list, but you can do that with these methods as well. Second thing about tuples, if I want to create, let's say, a list with one element, I want to create a list with one element. I would put square brackets, put one element inside, and I will get a list. Yeah, list with one element. It does work like that. But when I want to create an tuple with one element, for example, like that, what will I get? I will get integer instead. Or maybe I want to put a string inside, I will get string instead. Why is that? It is because the way Python works. So round brackets with one element doesn't say Python, it's a tuple. Because Python sees an integer inside the brackets, and that's it. We know we can use brackets for like math equations where we can add stuff and choose an order. So when you leave it like that, Python doesn't see a tuple with one element. Python does see an element inside brackets. So if you want to do a tuple with one element, you always need to add comma here inside after the element. So this way you will get a tuple. And the reason for that is that numbers can't have commas. So if you have something inside brackets with a comma, this gives Python an idea that we are talking about tuple, not just an element. So you can use it this way, and you will create a tuple with one element, just in case you need that. And after that, I will come back to our courses. I changed brackets. Courses have round brackets now, and the data type is changed also. So if I check the type of courses, I will get a class tuple. Yep, class tuple. So what can I do with tuple? We know that it is not changeable. I can actually check it by using a PyCharm snippet. So what I will do, I will write courses, place a dot, and look at the available methods. Count and index, and that's it. We don't take double underscore, these are for object-oriented programming, but if you look at these snippets, you only have two methods to work with tuples. So let's try. Count. Count, I put math here. 1. What does this mean? This means that math is only, there is only one math inside this tuple. So if I copy it, let's say, add a couple of more, math, and check the count method, I'll get 3. So we can count something inside tuple. Second thing, courses index, math, for example, we can get an index where the first math is located. So pretty much same as we had to find in strings. But we only get first occurrence, not all of them. So index does have a start and stop similar to find. So it's pretty much same method, but to work with tuples or lists, because these methods count and index will work with lists as well. So you can count something in list and you can index something in list. So these methods will work with lists too. But the thing with tuples is that tuples are not changeable. This means I can actually index something, for example, say courses 6, and get the result from there. But what I can't do, I can't say that courses 6 is now equal, I don't know, to something else. This will cause an error. Why? Because you cannot change anything inside tuple. Tuple is immutable. That's why we don't have any append, insert, extend, remove, or any other methods that do some changes with the tuple. You can actually still use min and max because these are not min and max are not list methods. They are just regular Python methods, so they can be used with different stuff. But if we speak about tuples, that's pretty much it. So tuples are immutable, and you can't do anything with them. If you want to change something inside tuple, you want to change something inside tuple. For example, I want to change math to something else, let's say economics. What can I do? I can convert tuple to a list by using courses equal list courses. So what I did, I changed this data type from tuple to list. And if we speak about uniqueness, I will print ID of courses here, and I will print ID of courses here. So by converting from tuple to list, we have a new ID. So basically, it's not the same element, but it's a new element created within. So it's not the same. We didn't change tuple now. We created a new list from tuple and saved it to the same variable. But now I can do, for example, courses. Let's say what I wanted to do. I wanted to change math. So I'll say history. I'll take first index, say it's equal to economics. Then I can change it back to tuple courses, and print courses. So that's the only way to do some changes in tuple. You just convert it to list, do your changes, and then convert it back to tuple, so your data type will be the same. Otherwise, you are not able to change anything. Tuples are unchanged. And you can also sum tuples, same way as it was with lists. I won't be using variables now. I'll just say I have 1, 2, 3 tuple plus 4, 5, 6 tuple, for example. So you can sum tuples. It works the same way as it worked with lists. So you just add another one tuple inside another tuple. But in the end, ID of this one and ID of that one are different from what you get in return. So it's not the same tuple. You didn't change first tuple by adding 3 numbers from second. You just created a new tuple that was combined from 2. So it's still not the same element. Any questions? Well, one question that I was expecting but didn't get, where should I use lists and where should I use tuples? It's quite easy. Mostly you will use lists because you want to do some changes inside. But tuples are used where you are 100% sure you won't be changing the values. So maybe some settings for your program or maybe something like that. So you just, if you want to be sure that for some reason you accidentally won't change any values inside, you better use tuple. Otherwise, use lists. So there's nothing to add about tuples anymore. So these are tuples, but I will copy courses again, put it here below, and now I will change brackets to curly brackets. And I'll check a type of courses and print courses as well. So, first of all, curly braces in that case are used by sets. I already told you that dictionaries also use curly braces, but sets and dictionaries are very different when we look at them and at their elements. That's why you can never mistake if you creating a set or a dictionary, the different ways of creating these types. I will speak about dictionaries later. But if I go back to this table and look at set, I will see that set has no duplicate members. And how can I check it? I have math written 3 times in here. But no matter how many times I write math inside this set, I will never get it more than once when I use it. So if we look at an output, we have only one math. And it doesn't matter how many times you run, you will always have one math. So we get rid of duplicates as soon as we have a set. So you can actually write duplicates inside set, or maybe you convert list with duplicates into set, but duplicates are deleted straight away. So you get rid of duplicates by converting to set or when you have set with some duplicate data. Second thing, if you look at this table, you see that set is unordered data type. So set doesn't have any order. What does this mean? First of all, I will be printing this set and look at the output at the bottom. You can see that order of strings is always different. So we can never count on a set's order because set stores elements without indexes. There is no order inside sets. This means we can't index anything. I can't take courses one. It won't give me some random value. Uh, so I cannot index and get something from sets. I can change set in some ways. I will show it in a while. But the main reason for set is, first of all, getting rid of duplicates. Second thing is couple of special set methods for comparing one set to each other and finding, for example, similarities and differences between two of them. I will show these methods too. But before I do that, I want you to see how can we create an empty set. So, of course, we can create it with a set method. It's not it's not something new for us. So set method creates an empty set. And if we speak about list, tuple, and set, if we have empty list, empty tuple, empty set, it will convert to Boolean false. If it has at least one element, it will always convert to Boolean true. So empty set, empty tuple, empty list will convert to Boolean false, same as empty string. If you have at least one element in any of them, it will convert to Boolean true. So we can also, of course, we can do empty set like that, but we can't do empty set with curly braces. The reason for that is by default, curly braces are type dictionary. So you cannot create an empty set with curly braces. So you have to use a set method to create empty sets. But lucky for you, you don't actually need to create empty sets often. So let's go back to set. So we don't have any order, and we cannot index any stuff. So actually, unordered and no duplicate members is true. Cannot be changed, but can be added and non-indexed. So basically, what that means that you cannot address an element like we did before, like courses 1 equals 2. We cannot do that because we know that set doesn't have any order, doesn't have any indexes. What makes it unchangeable? But there are methods to add and delete from a set. So let's see. Courses dots. So first of all, we have a copy method. uh, you don't need to type copy method. It's for the same reason I showed you with lists, and actually tuples cannot be copied this way. But lists and sets can be copied from one variable to another by using copy method, same as list I showed you before. We can add something into set, for example, economics. So add adds to a random place. That's why we don't use append method. It could be easier if we had append method here, but we don't because because set doesn't have last place. So add works as a random. So you just put somewhere inside. You have also courses dot remove method, and remove method works the same way as in list. So you have to provide the value you want to remove. You also have a pop value. Pop value does get a value of a deleted element, so you can store it in variable same way as it was with lists. But what you need to understand, you can't put any arguments inside pop using pop with sets. Why is that? Because there are no indexes we can use. So what pop does, it actually pops or takes, deletes a random element from our set. So if I do it now, what I see that physics is here. 1231 was deleted, and then when I use it one more time, I see that what's programming is here, history. No, history is here, literature was deleted, and so on. So every time you run this program, different value will be deleted, just a random one. So you can use pop. What is a strange thing here? So if I do a new variable, let's say nums, and make a set of numbers, for example 5, 10, 34, 21. Let's do a couple negative numbers as well. -5, -2. Let's put a 0, -25, for example. And I will print that. And I'll do it a couple of times. What you can actually see that numbers in this set, but we have integers inside. Integers in this set are always on the same place. So every time I run it, the set with numbers doesn't change. So you might say, all right, set does have an order when we have a numbered set. And you will be right from one side point of view, but from other point of view, you don't have any means to address this order. So you can't take first, second, third number, and so on and so on. So the using sets with numbers acts a little bit differently, so it doesn't show you some randomized results, but you still cannot address this order. And the second thing, that it's not in the same order it was in original. And another thing, it's not ordered in any way. So it's not from the least to the greatest. It's not from zero to something else. So we have negative numbers here, and we have positive numbers in between. So actually, never count on order inside even numbered sets, because you can do nothing with this order. You just can look at it and see, okay, it's on the same place. Um, Okay, I will delete this. You can comment it out. Let's see what else can we do with sets. Courses dot. So we can clear a set. Clear set basically makes an empty set of set with elements. I won't be even showing that, so it's just clear set. We can update. Update means that we can use, for example, a different set to add its values to existing set. So update method adds some other sets numbers. Actually, it not only sets numbers. I can put a list here, for example. Update method takes any iterable. Courses dot what else? Discards. All right. So with basic methods, that's pretty much it for sets. I will comment out this part on the top, and I want to show you special methods for sets. And for that, I will actually create another couple of sets. I will do it this way. I say set one equals to, let's say, math, physics, uh, history. Let's do economics, for example, economics. And set 2 will consist of two elements from previous sets and two new elements. Well, for example, I will take physics and economics, and I will also add something new like art and programming. So I have physics and economics in both, and then I have math and history in first set and art and programming in second set. So they have some differences and some similarities. So what we will do with these things? First of all, I'll do a print statement and say set one dot, and we have an intersection method. Intersection set two. Intersection set 2. So what I get? I get another set in return. Uh, and this set consists of elements that are present in both sets. So basically, what similar is there? So both of them have economics, and both have physics. This means that when we speak about intersections, it doesn't matter which set is on the first place and which set on the second, because if I change these, it doesn't change a thing, because both of these sets have two items, two similar items. So speaking about intersection methods, it doesn't matter in which order you provide the sets, but we have a, let's say, mirrored method, and this method is set one difference and set two. And I will take it, I will print it two times. The other one I will change the numbers of sets. So in first we have one and two. In second we have two and one. Uh, in difference method, it is very important which set is first and which set is second, because difference looks for special values for each set. And if we do set1 and set2, we can read this line as what is different in set 1 compared to set 2. And we can see that math and history. So there is math and history in set 1, and there are no math and history in set 2. So how is set 1 different comparing to set 2? And if we change the names of the sets, we can read it as how set 2 is different from set 1. And we see a different result, art and programming. So there is art and programming in set 2, and no art and programming in set 1. So these two methods are actually methods that are, let's say, unique for sets. And this is the second reason why we need sets. So first reason is to get rid of duplicates. And I will show you that example again. I will create a list. I will name it X. And what I will have here, I will have, let's do strings. I will do 1, 1, 2, 3, 3, 4. That will do. So what if I want to get rid of duplicates in this list? I can convert it to set and then back to a list. And I can do it in one line actually. So I can say x is equals list set x, print x. List set. So what happens here? I first of all convert list to set. I will remind you that methods in brackets are working from inside to outside. So first operation is we take a list X and convert it into a set. We know that set doesn't allow any duplicate members. This means that by converting it to set, we delete all of the duplicates and then convert it back to a list to have a list in the end. But if I run this program, you can mention that our order inside the list always changes. This is one of the things that set does. Basically, set doesn't have an order. And you can use set to get rid of duplicates, but you need to understand that your order of the list will be changed too. So if you need elements inside the list to be ordered in the right way, you might consider not to use set and use some other techniques we will learn later. But easiest way is to do it so. And you will have one home assignment later. We will be looking at working with files, and this will be for Python group, not for data analysis. So we will be working with files, and you will get a text file book that where you will need to count how many words there and how many different words are there. So basically, if you counted one word once, you won't be counting it twice. So how many different words there, and you will need a set there to get rid of duplicates. So this is one of the ways you can do this. Yeah, we do it here. So set X converts it to a set, gets rid of duplicates, changes the order as well, and then by adding list method here, we convert it back to list. Because if you look at the brackets, these are square brackets, it's a list. So this is one of the ways using set. Second is these intersection and different methods. So basically you might have one set of data and another set of data, and you need to see, are they different or are they same, or and so on and so on. So that's another reason for that. No, no. When you convert list to a set, it does get rid of duplicates. So by converting to set, you change the order and that's it. It gets rid of duplicates, changes the order. You can't do anything with that. Because set itself doesn't store any order. So you can't provide it. So it is like it is. There will be there will be other different ways of doing it. So no worries. Okay, we have some time left. And what I want to do with you, I want to explain you a couple of workflow constructions. I will do that quickly just for you to get a glance at it. And then next lesson, we will continue watching them and see more examples. First thing I want to show you is a, just give me a sec. First thing I want to show you is an if-else if statement. So when we speak about programming, there are actually three main flow control constructions. It's an if-else if else statement, it's a for cycle, and it's a while cycle. And if you take any programming languages that exist, you will pretty much find these constructions in one way or another inside these languages. Let's say C, C++, Java, JavaScript, PHP, Ruby, Python, and whatever, they all have these ways. That's why uh, I always tell that programming is not a programming language. Programming is a concept that was created long time ago, even before we had any programming languages. But programming languages is just a syntax. So basically, you do the same programming, same algorithms, same logics, but with a different language. And the thing is that if-else if statement is a construction that helps us make decisions, that helps us execute code when some condition will happen. So in Python, actually, I can double check. Nope. I'll open you one diagram. I think it will help you to understand it better. Uh-huh. Mhm. Mhm. We'll open you a diagram of how if statement works. So each this is a group of statements: if, elif, else. So we have three different keywords. So it always starts with a if. If something happens, maybe some condition, x is equal to 5, x is greater than 5, and so on and so on. So we always need to get a boolean inside the condition. The result of condition must be a boolean. So it's either true or false. And then we say if something happens, for example, it's true, it did happen, then we do a body of if condition. So basically we execute code inside if and get out of the whole construction. So this means that if first condition is true, we don't check any other conditions we have. We just do whatever we need to do. If first condition is false, you may have, it's not like 100%, you do have a leaf statement, but you may have a leaf statement. So if first condition is false, then we check next condition if we have any. If we have condition that returns true, we complete body of that condition and get out of the construction. If this condition returns false, we may have another elif statement. So if that's no, if that no, elif No. We may have a lot of different conditions. So if all of the conditions return false, then we can have an else statement. Else means that in any other situation. So if all of the conditions before return false, we will use else if we have else. So it doesn't matter how many conditions you have here, you always execute only one block of code. The first condition that returned true. So how it works in Python? In Python, if conditions are built with an if keyword. So we start with the keyword if. Then we put a space, and after that we need to create a condition. Condition must return true. So what we can do with that? We have comparison operators. Uh, mhm. We'll open that. In Python, we do have a comparison operators. Remember, I told you that single equal sign is not equality check. Yep. If you want to check if left side is equal to right side, we can use double equal sign. So that checks if left and right sides are equal. And these are comparison operators. They always return you Boolean as an answer. So if I do um, something like print 10 equals 20, I will get false because it's not. 10 equals to 20, or maybe 10 equals to 10, true. Or maybe 10 equals to 10 like that, it's false because of the different data types. So, and so on and so on. So comparison operators are always returning booleans. This means that if I compare two values, it doesn't matter which values, it can be different type values. If they are not equal, I will get false. If they are equal, I will get true. So using these operators is a good way to create conditions. We have a not equal. So if we get true when both sides are equal, here we will have true if they are not equal. So just an opposite. We have a greater than, less than, greater than or equal to, and less than or equal to. So there's only six. Pretty much they are all same comparison operators you had in math at school. And with these conditions, with these operators, we can actually create if statements. Let's say I will have x equals to 5, and I will write an if statement where I will say if x is equal to 5, I put a colon in the end. For Python, this means that I finished with building my if statement. And now I have this tab here. Tabs in Python are four spaces. And Python is a tab sensitive, indentation sensitive language. In other languages, you would have something like, well, let's say curly brackets here that say that everything is inside curly brackets is a part of if statement. In Python, we don't have any. So we just put a colon, and everything that is indented here counts as a part of if statement. So I can write here print x is equal to 5. And these indentations are exactly 4 spaces, but I recommend you to use a tab button for those. So exactly 4 spaces, that's a Python standard. So if I run this code, I will get, just give me a sec, I'll comment everything on top. Comment everything on top. So if I run this code, I will get this message. Why is that? Because x is equal to 5, and that's true. If I change x to, let's say, 6, I won't get anything. because this condition didn't work out. This condition will work only when x is equal to 5. This is the only way we can get true here, and then we can execute everything that is inside. So if x is not equal to 5, this condition is false. So we won't be using code inside. And if I have something else here, for example, print goodbye, that will work. This if statement works only for code with indentation inside. So basically, if we come back to this diagram, you see body of if condition and if statement condition. So we can say that this line is an if statement condition, and this line with the indentation is a body of if statement condition. So this is how Python understands that something is inside of other construction. So basically print x is inside if statement. Okay, maybe we have another condition. I have condition that x is greater than 5. We have x is equal to 5. I want to check if x is greater than 5. I can do that, but I can't use. Let's say, okay, I'll show it differently. Uh, elif is a shorthand from else if. This means if first argument or first condition didn't work, I have another one. I will add them to elifs. Elif is not compulsory. You saw if works fine without elifs. So if you don't have any second condition, you can leave it empty without elif. But if you do have second condition, you need to write it down. X is greater than 5. And you need to use elif for that. Let's say print x is greater than 5. So now we have this second condition working. What will happen if I change x back to 5? First condition will be working. So we have some logics now, and our program is possible to determine which part of code it needs to execute. So if x is equal to 5, we execute this line. If x is greater than 5, we execute this line. What if x is less than 5? We don't have any conditions for that. This means we don't execute anything. We just skip this part. I can actually add another condition. I can add another elif statement here saying, for example, x is less than 5. Do you think I need it? Are there any other variants of conditions, or that's the last possible condition? Actually, we only have 3 variants. So we have equal to, larger than, and smaller than. I can use it this way. I can say x is less than 5. It will work without any problem. But I don't actually need to write a condition because I only have one variant left. I can use else. Else means that when all of the above conditions return false, we only then use else. So else is pretty much in any other case. And else never has a condition. Else is always last part of this construction, and else never has a condition inside. So elif and else are optional. If you have something to add to else or elif, you can do that. but if is always a compulsory one. So if you want an if statement, if condition, you always start with if. Any questions so far? So I will do another example. I will comment this out and say that x is equal to 5 and say if x is bigger than 0, print, let's say x is larger than 0. And if x is greater than 3, print x is larger than 3. So what I have here is that I have two conditions that are actually both true. If you look at my x is equal to 5, so x is definitely larger than 0, and x is definitely larger than 3. So in this example, both conditions are true. But when I run code, I only get first condition. And the reason for that is, I'm going back to the same diagram. The reason for that, if you look here, you can see whenever you get a true, you just do a body of this condition and get out of the statement, the whole construction. Yeah. So I can do another one. I can do a leaf x is larger than 4. You cannot. You can don't write it, and print something else, and I can do many of those at 4.5, 4.9, and so on and so on. But I always get only one condition completed. So if you have different conditions and you need to check them both, for example, here I would like to know if x is larger than 0, and also I would like to know if x is larger than 3. Then you need to understand that by adding if and elif, 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 you create one construction. And this rule applies for one construction when you have if in the beginning and elif or else inside. But if we do change this to another if statement, this makes it two separate constructions. So these two are two different constructions, and this means they will both be checked. So it depends on what you want to achieve. If you want to achieve that you check only one condition from some amount of conditions, okay, you use if, elif, 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 else. If you want to check all of the conditions, you can start each of the conditions separately with if. Any questions? Okay. And another thing, as we are moving here, you can find these comparison operators. I will add it to strings lesson in cheat sheets folder. I will add them too. What I want you to know, you have another thing here, and this is called Python logical operators. So you have and, or, and not operators. And if you look here at examples, you see that these are used to combine conditions. So combining conditions. I'll give you an example. So I'll say that x is equal to 5, and I want to check if x is greater than 0 and less than 10, for example. So I can do it this way. If x is larger than 5 and x is less than 10, print array. Less than 10. If is, let's say larger than 0, not 5. X is more than 0. and less than 10. So how it works? If we have an AND operator, AND checks if left and right side of the AND return true. And AND will return true only in case both of the sides are true. So when I had this example with 5 here, x is greater than 5. Is it true? No, x is equal to 5. So this part return false, and won't even check second part, because if it's false here, then the whole this and thing is false, so this condition won't work. But if we have 0 here, this condition is true, this condition is true. That's why we get a body of if done. If we, for example, want to check either conditions, so for example, I want if x is larger than 0 or x is less than 0, print not a 0. So if I have x equal to 5 or minus 5, for example, I will be getting a not a 0 message. But if my x is equal to 0, I won't be getting anything because I don't have this condition here. It's either less or more. So when we say or checks if one of the conditions is true. So AND checks both conditions and returns true only then when you have both conditions returning true. And OR returns true if one of the conditions returns true. It's either left or right. So this way you can combine different conditions inside the if statement. I will speak about if statement a lot more next lesson. I will show you more different examples as well. But for now, I think that should be enough. I still need to think about your homework because we should be looking at that last lesson, but it took us a little bit more time. But that's not a big deal. I'll just create different homework for you using if maybe and lists, tuples, and sets that we learned today. And next lesson, we will be doing different flow control constructions. So we will look at both cycles, for and while cycle, look at the differences, learn how to use them. We will be using an if statements as well. And we will start doing a program to check to work with your Estonian national ID. So I guess all of you have it. And we will be writing a small program to, for example, get your date of birth or check your gender by your national ID. So we can do this, or check if your national ID is real or you just wrote a random number. So I think that's it for today. Do you have any questions? All right, then I will stop the recording.